Hello, my pancreatically challenged friends. My name's Curtis, I'm a fellow type 1 diabetic, and today we're going to be looking at a type 1 diabetic foundational lesson, how do blood sugars work, or how do they want to work. If you're just starting with type 1 diabetes, it's a great place to start. This will be a foundational bit of knowledge that will stay with you for a long time to come. Or if you're wanting to upskill your diabetes, you've been at it for a little while, this is a great place to start to make sure you've got a solid foundation. So how are we going to learn about this today? Well, we're going to start by having a look at non-diabetic blood sugars. It's really important to understand those because by understanding them, we get a rough picture of what we're trying to replicate as type 1 diabetics. So we'll go through the process of non-diabetic blood sugar regulation to start with. We'll then transition into looking at how it impacts type 1 diabetics when we're having to do our own manual insulin injections. So we'll look at it in a simplified way, but we'll also understand how that simple theory has a bit of a complex reality in how it actually shows up in our day-to-day life. Those first two parts, we're going to keep it nice and simple, just giving you the essential information you need to know. On the final part there, the homeostatic blood sugar regulation, we're going to go that one step further so you understand some of the cycles and systems in the body that you can try and use to upskill your type 1 diabetics. Not essential knowledge, but it will really help you if you're looking to push your diabetes to that next level or your understanding to the next level to ultimately help you get a lower A1C, increase your time in range, and do it without the burnout. Let's crack on. So first, we talk about non-diabetic blood sugars. It's a really good idea to just start with what's the body trying to do, the non-diabetic body. So at all times, the body is trying to pull your blood sugars for non-diabetics into the ranges on the screen there. That doesn't mean they always sit in there. They do go higher and lower than this, but it's always trying to pull them back into this range. And to do that, it has to have two things. It has to have the ability to lower blood sugars when they're too high, and it needs to also be able to raise blood sugars when they're too low. Keep that in mind, it'll come around a bit later. But for now, let's have a look at the basic process by which we get glucose into our body. So starting on the left here, food is the primary source of glucose for many of us, primarily carbohydrates, which are broken down into their smallest building blocks through digestion, and their smallest building block is glucose. That breaking down mostly happens in the stomach, but does happen in other parts of the body. And the absorption, which is the transfer of glucose from the food we eat into our actual bloodstream, happens mostly in the small intestine. That's your main source and probably the one you've heard about. The other source, which you may be unfamiliar with, is the liver here. The liver provides a constant background trickle of glucose into the bloodstream as well. At this point, it's useful to consider the bloodstream as a big closed loop, and that just continues to go around. Now, you may also have heard that this is where the pancreas and insulin comes in. In order for us to get glucose, which are the little yellow dots in our blood vessel there, out of that circulating system, we need insulin to allow them. The analogy we often use is the key to the cell to move from the bloodstream into the cell. And why do cells need glucose? Well, it's so they can burn it as energy, which allows them to keep doing whatever they're doing. For a heart, that might be pumping. For your brain, it's thinking. And for your muscles, it's doing work, moving up and down, back and forth. At this stage, it's also worth mentioning that glucose can move from the bloodstream into your cells via another mechanism, which is through exercise or movement. It's just worth noting at this stage, you don't really have to focus on it too much, particularly if you're at the early stage of your diabetes. You'll learn that as time goes on. But for now, it's worth noting. So let's have a look at type 1 blood sugars. This is the exact same pathway which we're going to start with, and we're going to identify a few of the bits that are a little bit challenging when you don't have your own insulin. And that is the first point to make in this diagram, that type 1 diabetes is an autoimmune condition that reduces or eliminates your ability to produce your own insulin. So we have a look here, the pancreas there can no longer produce our insulin. And what that means is that glucose gets stuck in the blood vessels, or those pipe system that we were talking around. And that means no energy can get into the cells. But luckily, your body does have a plan B. It can use things called ketones, which are produced from the liver here, and the liver can produce those, and they will go through to the cells across your body, which can then be burnt as energy. Now, there's two problems with this. The first is that that process is less efficient for the cells, so they need more ketones to do the same amount of work as one bit of glucose would. And the second problem is is that the liver overproduces these ketones, and it produces them more than what the cells have the ability to process them. The end result of that is your blood, these ketones literally make your blood more acidic, which means that your body goes into a state of diabetic ketoacidosis. So it's not meant to be a long-term solution, and if you can't get the glucose into the cell, it's forced to keep pumping out these ketone bodies. So the body does have a plan B, fortunately, to get glucose out of that circulating system, which is why you might understand some of the early onset symptoms with type 1 diabetes. So if you've got a high concentration of glucose, it'll often send it to the kidneys to try and be peed out, and this will have secondary impacts of increasing your thirst that's your body telling you to try and dilute your blood to literally reduce the concentration of your blood sugars by drinking a lot more. The combination of these really high glucose levels and also the rising acidity from the ketones or the diabetic ketoacidosis is often why you feel like absolute rubbish before you're first diagnosed, and why you might be losing a little bit of weight as well, because your body is breaking down a lot of your fat stores. So what's our job as a type 1 diabetic? What are we trying to do? Well, as you might have already guessed, we are trying to manually add that insulin in to match the sources from our eating and from the liver. We give our insulin via an insulin pump or via injections, which you can see on the screen here. And once we unlock those blood vessels again and we can move glucose into the cells, it allows us to be less reliant on that kidney pathway in which we're trying to excrete a lot of the excess glucose. It also means we no longer have to rely on ketones to fuel our cells, and we can bring our cells out of the state of diabetic ketoacidosis. So really the simple theory is that we're trying to match the food we eat plus the glucose that's coming from our liver with the insulin we give. And that may be the simple explanation you've been given from your healthcare team. And on the next slide, we'll look at a little bit more of the complex reality, which is a bit more challenging. So at the top there, we have our same little diagram. Our food plus the liver brings the glucose in, and we're trying to match that with the insulin that we're giving ourselves. So this is a simplified way of looking at it, and we can see there's 3 variables there. And these are 3 common situations. The first one there, if you match your insulin perfectly with the glucose that's coming from your food and your liver, you're going to get a nice sort of flat line on your CGM graph like that. The other option is if you don't give enough insulin to cover the glucose that's coming from your food and the liver, well, you might end up going high into a state of high blood sugars because the insulin, there's not enough there to do what it needs to do. And the third common situation is if you have too much insulin and there's not enough carbohydrates or glucose in the food or coming from the liver, you will go low and your blood sugars will go low. Now, unfortunately, with these 3 variables, the reality is they're not stagnant, they're not static rather, even throughout the day. Your insulin sensitivity will change throughout the day and across your lifespan in weeks to months. Same with food. No one wants to eat the same meal every day, so you're not always going to be able to lock that food variable there of the little equations we have up. And the liver, even the amount of glucose being trickled out changes throughout the day and across your life, weeks to months as well. So the reality is your CGM graph, instead of looking like those nice sort of clean, simple examples there, may look something a little bit more like this. Some highs, some lows, some peaks and troughs. But don't worry. This is type 1 diabetic foundational knowledge here, and with a little bit of effort and some more upskilling on your part, you'll definitely be able to eat whatever you like and keep a nice flat blood sugar range. It's definitely possible. So that's the end of our really simplified section of understanding the basics of type 1 diabetics and how blood sugars work for both non-diabetics and diabetics. In this next session, if you want to take the next step forward, we're going to have a look at the different homeostatic pathways that the body can use to regulate its own blood sugars. All right, it's going to be a big slide on the next one, so stick with me. As I said, there's a lot there, but let's focus on the top left corner and center ourselves. So remember early on we said that the body is constantly aiming to try and get your blood sugars between the ranges in the top left corner there. Now to do that, you'll also remember we said it needs to have the ability to raise blood sugars when they're too low, and it needs to have the ability to lower blood sugars when it's too high. And that's, you'll see on this diagram, there are actually 2 separate cycles. There's the red arrows here, which form one pathway, and then there's the blue arrows, which form another pathway. So I'll quickly run you through those. If we start with high blood sugars at the top here, the brain and the body can sense that the glucose is too high in the blood, and it promotes the release of insulin. So it tells the pancreas to release insulin. And insulin actually does two things. We covered the first one in our simplified explanation, is it stimulates glucose uptake from the body. So that's the same as being the key that opens the cell door to allow glucose to move from your blood system into your cells. Now, if we're taking glucose out of the blood vessels, well, that's the same net result as lowering blood sugars. So insulin will always act to lower blood sugars. The second part, which we didn't touch on in the simplified example, was that insulin actually also stimulates glycogen formation. So what is glycogen? Well, the liver has the ability, in times when we have excess glucose circulating around our system than what our cells actually need in that moment, it can package them up and sort of put them on a shelf for later. And that's important because we can't keep glucose in its current form just circulating around forever. So your body's pretty smart and it packages it up as glycogen. When we package it up as glycogen, that's the same thing as taking it out of circulation, out of the blood circulation. So it has the same effect of lowering your blood sugars. Now, in a non-diabetic body, this process continues, and if the blood sugars go too low, you can see down the bottom here, we follow this blue arrow now, we've got low blood sugars. So the body detects this, picks it up, and tells the pancreas to now promote the release of glucagon, a sort of brother or sister hormone to insulin. Now, what glucagon does is it stimulates or tells the liver to start breaking down or unpacking the glycogen that we'd stored previously with insulin. And you can see here that the liver has the ability to turn glycogen into glucose as well. And then it pumps it out into the bloodstream. So if we're increasing glucagon and releasing more of that glycogen into glucose into the bloodstream, well, the net effect is we raise blood sugars. And the non-diabetic's body continues on this cycle, constantly turning these different sides of the seesaw, if you will, on and off to try and pull its blood sugars within range in the top left corner there. Now, you might think as a type 1 diabetic, great, I only don't have insulin, that's the only part I really need to understand and work towards. But unfortunately, that's not quite the case. In type 1 diabetes, even when we have low blood sugars, you might expect that the glucagon production would be amped up. But unfortunately, type 1 diabetics have an impaired glucagon response, which means that when our blood sugars are low, we're not going to get as an effective blood sugar raise, which is the blue arrows here, that you would expect in a non-diabetic. Additionally, if we have high blood sugars, we are actually often experiencing a lingering effect of glucagon. And what I mean by that is there's more glucagon circulating in our system when our blood sugars are already high than you would normally expect in a non-diabetic. And that's a problem because, as we've discussed, glucagon acts to raise your blood sugars. So if your blood sugars are already high and you have more glucagon than you need, they're going to continue to be high. So that's the next step. It can definitely get more complex than this, but this is a great intermediary step for you understanding how the human body wants to work and what you're trying to mimic and change as a type 1 diabetic. So we've understood non-diabetic blood sugars in the body and how it works, and a light picture for us to replicate. We've covered some simple theory and the complex reality of type 1 diabetics, and I really hope you've enjoyed this foundational knowledge. It's really a foundation to understanding your body, how it works, lowering A1C, increasing time in range, and reducing your burnout. That's all for this time. Next time, we'll have a look at the science behind CGMs.